This video is on solving quadratic equations by graphing. Another method for solving a quadratic equation is to graph it. To find the solutions of the equation ax squared plus bx plus c equals 0, we can graph its related function, f of x equals ax squared plus bx plus c, and find where f of x is equal to 0. Those are the x-intercepts of the graph. Those are going to be the solutions to the equation. So in short, we want to graph the related function and find where it crosses the x-axis. So let's take a look at a couple examples here. So our first one says we need to solve x squared minus 2x minus 8 equals 0. So I'm actually going to graph y, or f of x, is equal to x squared minus 2x minus 8 and find where it crosses the x-axis. So remember, in order to graph a quadratic function, I need to find the coordinates of the vertex, and you'll recall from previous lessons that the x of the vertex is negative b over 2a, or in this case that's going to give me 2 over 2 or 1. So the x of my vertex is equal to 1. And then when I plug in 1 into the function, I will get a value of negative 9. So my vertex is going to be 1, negative 9. So here I think I would like, let's go ahead and graph that, 1, negative 9. Okay, so I think I would like to make a table of values because I know that this graph is going to open upwards, but I need to find what are those places where it crosses the x-axis. So let's just make a little table of values here. And I'm going to start by putting my vertex in the middle. And when I plug in 0, I know that that's going to be my, negative 9, that's going to be my y-intercept of negative 8. Okay, and 2 is also going to give me negative 8. When I plug in 3, I get negative 5, and that's going to give me the same for negative 1, because I know that this graph has to be symmetric. And when I plug in 4 into f of x, that's going to give me a value of 0, which is exactly what I'm looking for, and negative 2. So let's go ahead and graph those points. So negative 8 and then negative 5. And 0. So my graph is going to look like this. Okay. And these right here are the values that I'm looking for. Where does this graph cross the x-axis? And that's going to be at x equals negative 2 and x equals 4. Those are the solutions to the quadratic equation. Those are the points where f of x is equal to 0. And I can actually even see that in my table right here. When f of x or y is 0, x is equal to negative 2 and x is equal to 4. Let's take a look at another example here. Here I have x squared plus 2x plus 3 equals 0. And I want to find the solution, so I'm going to figure out I'm going to graph the related function, f of x equals x squared plus 2x plus 3, and I'm going to find when does that equal 0. So to find the x of my vertex, that's negative b over 2a, or my x is going to be negative 1. And when I plug negative 1 into the function, I get that f of x or y is equal to 2. So that's going to give me a vertex of negative 1, 2. So negative 1, 2. That's going to be my vertex. Now I'd like to make a table of values to find the rest of this, to find where it crosses the x-axis. And that's going to be negative 1 and 2. I know that my y-intercept when x is 0 is going to be 3. So that's going to give me negative 2 is also equal to 3. And when x is 1, y is 6. And when x is negative 3, it's also going to be 6. So let's take a look at what that looks like when we graph it. And 1, 6, negative 2, 6. You'll notice from this graph that this quadratic function is never going to cross the x-axis because my vertex is above the x-axis and the parabola opens upward. I can also tell this by looking at my table here, because here was my vertex, okay, and I notice that these points are actually getting larger. Okay, I never see my points heading towards the x-axis or my y's getting negative. I also notice this because this vertex right here is above the x-axis. My a value is positive, so I know it's going to open upward. So this quadratic equation has no real solutions. I think it's actually interesting that you can tell a lot by not just looking at the graph, obviously, but also by what the table is telling you, the values in the table. So here are a couple quadratic equations I'd like you to try on your own. Negative x squared plus 6x minus 9 equals 0, and x squared plus 6x plus 6 equals 0. Stop the video and try these in your math journal. Okay, let's take a look at this quadratic equation. I'm going to graph the related function and try to find where does f of x equal 0. So to find the x of my vertex, I'm going to do negative b over 2 times a, or x is going to be equal to 3. And then when I plug in 3 for x, I get that f of x is equal to 0. So that's going to give me my vertex, 3, 0. And actually, I think this is telling us a whole lot already about what this is going to look like. But let's go ahead and make a table of values and see what happens here. So 3, 0 is my vertex. I'm going to pick some numbers smaller. Whoops. And some numbers larger. So when x is 2, I get negative 1, and that's also going to be true for 4. And when x is 1, I get negative 4, and that's also going to be true for 5. So let's see what this graph looks like. So 3, 0, and then 2, negative 1, 4, negative 1, and 1, negative 4. Okay, so there's what my graph looks like. So this has one real solution, which is this point right here, x equals 3. And this is an example of a quadratic equation that has one solution because its graph only just touches the x-axis. It doesn't actually cross it. And to be honest, I could have seen this in the table because I saw that my vertex had a y-coordinate of 0. So that means that this x value is going to be my one and only solution. And let's take a look at our last example here. X squared plus 6x plus 6 equals 0. So I want to graph f of x equals x squared plus 6x plus 6. Let's find the x of our vertex, negative b over 2a, or x is going to be negative 3. And then when I plug that into f of x, I get that f of negative 3 is also equal to negative 3. So that's going to give me this point right here. That's going to be my vertex, and I know this is going to open upward since a is positive, so I will have two real solutions there. So let's make our table of values. Negative 3, and then let's do negative 2 gives me a negative 1, and negative 4 is also going to give me a negative 1. And when x is negative 1, I get a positive 1, and when x is negative 5, I get a positive 1. So let's go ahead and graph these points. So negative 2, negative 1. Okay, I'm sorry, I got the wrong points here. This one is actually supposed to be a negative 2. And I saw that because the graph didn't look like what it was supposed to look like. There we go, that's better. All right, so I'm sorry, those, instead of being negative 1s, those should be negative 2s. So this point here, and then when x is negative 1, y is 1. When x is negative 5, y is 1. And my graph looks like this. So this is a little curious. So looking at my graph, I can see that I have x-intercepts right in here and right in here. I also notice that my graph does not cross the x-axis at an integer or at a nice point. In fact, it looks like it's between negative 2 and negative 1 and between negative 5 and negative 4. Well, let's go back and look at our table. You'll notice that in my y values, right in here, my y goes from being negative to being positive. That's represented by this point right here, where the graph crosses the x-axis. My y's are no longer negative, now they've become positive. Same thing is going on here between x equals negative 5 and x equals negative 4. My graph goes from being negative y's to being positive y's. You'll also notice that as in our other graphs, there is no y value of 0. Okay, so that means that my x values, my solutions are going to be between -4 and -5, and between -2 and -1. Here's how I write my solution. So -5 is less than x is less than -4. Literally, that means that x is between -5 and -4, and -2 is less than x is less than -1. Literally, x is between -2 and -1. And don't worry exactly what those points are. At this point, it's just good to know that it's somewhere in between. If you were to graph this on your calculator, and you could actually figure out a decimal approximation to what those values are. So in this video, we took a look at how to solve a quadratic equation by graphing. That is by graphing the related function and finding where it crosses the x-axis. What are its x-intercepts? We saw that you can have two integer points, two integer solutions. We saw that you could have one if the graph just touches the x-axis. We saw that you can have no real solution if the graph will never cross the x-axis. And we also saw in this fourth case that you can have two real solutions, but they are not integers. They're going to be between two integer values.